Hello student, this is Rimpa Singha Roy. I think you remember this law, right? We have learned it in the previous lesson. What is the name of this law? So it is associative law. We have proved this law in the previous lesson through Venn diagram. But if I say you are not allowed to use the Venn diagram, but you have to prove this law. So how do you do this? So here in this lesson, we are going to learn about the proof of this associative law without Venn diagram. So without any further ado, let's get into the lesson. Here we first need to know that how to prove two sets equal. So here are two sets A and B, and I need to prove this two sets equal. So how do you do that? So for this we need to prove that A subset of B and B subset of A is similar to the number system. If we need to show that A is equals to B, so then we prove that A less equals to B and B less equals to A. Then only we can say that A is equals to B. So here we will prove A subset of B and B subset of A. So then we can say that A is equals to B. So how do you prove A subset of B or B subset of A? So for this we'll take a point from the A set and we'll show that this point also exists in B. So then we can say that A is subset of B. Similarly, if we take a point from B and shows that this point also in the A exists in A, so then we can say that B subset of A. Now we are going to talk about some statement and its explanation. So the first statement is X belongs to A union B. So it implies that X belongs to A or X belongs to B. This sign implies or, okay, and this one implies and. If you have any doubt regarding mathematical sign, then please let me know in the comment section. I will make separate video on mathematical signs. So now as X belongs to A or X belongs to B, that means X belongs to A union B. As it is the union, so it can be in A or can be in B, then it can be in the union. It will be in the union. So here we use the or sign. But if we talk about the intersection, X belongs to A intersection B, then we will write that X belongs to A and X belongs to B, because intersection means the common region of both A and B. So then it must belongs to the both A and B. Okay. Now the third statement is X belongs to A complement, but X does not belong. That means X does not belongs to A. Okay. Now X belongs to A union B, its complement. So it means X does not belongs to A union B. As X does not belongs to A union B, so that means X neither belongs to A nor belongs to B. So we'll write X does not belongs to A and X does not belongs to B, because it does not belongs to union, that means it neither belongs to A nor belongs to B. So here we use the and sign just to signify that it neither belongs to A nor belongs to B. Now here the next statement is X belongs to A intersection B, its complement. That means X does not belongs to A intersection B. Now as we talk about the intersection, as X does not belongs to A intersection B, that means it can be in A but not in B. It can be in B but not in A. So here we can use the or sign. So use the or sign here. X does not belongs to A or X does not belongs to B. Now the next statement is X belongs to B minus A. So that means X belongs to B and X does not belongs to A. So these are the statement that you need to know to solve any problem. Now we'll prove the associative law. So how do you prove that? First we will show the left hand side is subset of the right hand side and the right hand side is subset of the left hand side. Okay. So for this we'll take a point, let x belongs to the left hand side, that means A union B union C. Now as x belongs to A union B union C, then I can write that x belongs to A or x belongs to B union C. Okay, so then I can write x belongs to A or x belongs to B or x belongs to C. Now we can write it as x belongs to A or x belongs to B or x belongs to C. Okay, so then I can write it as x belongs to A union B or x belongs to C. Then I can write it x belongs to A union B union C. We have taken a point from the left hand side, that means A union B union C, and we have shown that it belongs to A union B union C. So we can write that A union B union C is subset of A union B union C. So we have proved the left hand side is subset of the right hand side. Now we will prove the right hand side is the subset of left hand side. So for this we will take a point y belongs to A union B union C. So here guys, we have taken one element from the right hand side, that means A union B union C. Now we need to show that y belongs to A union B union C. Okay, so how do you prove that? So now I am going to share a trick with you. So the trick is, if you look at this line, it's similar to this line, and similarly this line is also similar to the first line. So we don't prove it actually, we'll just write all these lines in the reverse order and just change this x with y. Then we will get this proof, and we can write that A union B union C subset of A union B union C, and the proof will be completed. So we have proved the left hand side as the subset of the right hand side and the right hand side as the subset of the left hand side. So we can say the associative law is proved here. But before ending this lesson, let me tell you one thing. Yes, I have shared the secret with you to prove the second part. But sometimes some books and some teachers also recommend you to use the by implication sign instead of this implication signs. Okay, this implication signs. When you use this by implication signs, you don't need to do the second part. You will use this by implication sign and you will prove this part, and you directly write the proving statement. Okay, but some teachers also don't let you use this by implication signs and tell you to do this both part. So then you have to do this and you can use this trick there. Okay, so I'm not going to prove this second intersection law. It's going to be your home task. But if you face any problem regarding this proof, then you can comment me in the comment section. I will make a separate video on it. So till then, keep learning, keep growing. Thank you so much.